This question was asked in GATE 2005, where the power of the given signal x of t, which is sum of two periodic signals or sinusoidal signals. We have an observation point about the power of sum of different sinusoidal signals, that is a1 square by 2, a2 square by 2 and so on. This is the overall power of the signal. So from this we can take the power of this signal x of t, amplitude square divided by 2, and second signal amplitude square divided by 2. While calculating the power of the signal, we need to consider only amplitude of the sinusoidal signals. It is independent of frequency and phases. The power quantity or energy quantity of a signal, it is independent of the frequency and phases. All periodic signals are power signals, and the power of these signals depending upon only amplitudes of these two signals as per this formula. We have this observation point, so that here it is 64 by 2, that is 32, and this is 16 by 2, that is 8. So totally the power of this signal is 40 watts. So the right option for this is option A. Similarly, if you see the 2001 question about energy and power classification, we have x of t signal energy E. It is given that x of t signal energy is E, and then what is the energy of the given signal x of 2t. So t is multiplied with some constant k. So let us take the energy of x of t, that is integral minus infinity to plus infinity x of t magnitude square dt, and then energy of x of 2t, if we consider, let us take this one as E1, this one as E2. Of course he has given that this is E, let us take it as E, so that E2 it is equal to minus infinity to plus infinity x of 2t magnitude square dt. If you observe here we have 2t, let us consider this 2t as a new time domain variable tau, so that dt we can write it as d tau by 2, and we can observe the limits here. T value if it is infinity, tau also we can get infinity. If t value minus infinity, tau also minus infinity. So limits does not change for the tau value. So this can be written as minus infinity to plus infinity x of tau, and this dt we can replace with d tau by 2. So that it is 1 by 2 integral minus infinity to plus infinity. Here square is there. So x of tau whole square d tau. So this expression is nothing but the given signal x of t energy E. This quantity both are same. So that this is 1 by 2 E. So x of 2t signal energy E2 should be equal to 1 by 2 E. So that the right option for this question it is option B. Like that you can calculate. These questions were asked in GATE 2005 and GATE 2010 based on the topic signal operations here. First, if you see the question in 2005, it is asked that x of t signal shown in the figure, and then even and odd parts of the unit step function in terms of this x of t it is asked. So first let us find the even and odd parts of unit step function here. U of t, even part, it is given by the formula u of t plus u of minus t divided by 2. Odd part of step function, it is given by the formula u of t minus u of minus t divided by 2. So from this formula let us find first even part of the unit step function. If this is u of t and u of minus t reflection, if we add these two, so left hand side only one signal with the amplitude plus 1, right hand side signal it is only one signal with amplitude 1. So this is sum of these two signals u of t plus u of minus t, here amplitude it is 1, whereas to get the even part we have to divide with 2. So this amplitude we can divide with 2. Then this is nothing but even part of the unit step function, that is equal to 1 by 2 a DC function. Similarly, if we see odd part of the unit step function, reflected part should be subtracted from the original signal. So let us consider u of t and reflection u of minus t. Let us subtract here, so that here 0, this is 1, 0 minus 1, it is minus 1, left hand side, right hand side it is 1, this is 0, 1 minus 0, 1. So right hand side it is 1, and this is expression u of t minus u of minus t. To get the odd part of the unit step function we have divided by 2. So these amplitudes, let us take it is divided by 2. This signal is nothing but odd part of the unit step function, which we can also represent in terms of the x of t as, here x of t amplitude 1, here we are having 1 by 2, so that this is nothing but 1 by 2 multiplied by x of t. So it is 1 by 2 and 1 by 2 x of t is the answer. So 1 by 2 x of t, right option for this question is option A. Similarly, let us see 2010 question where two given signals f of t and g of t, and we can observe that g of t is with respect to f of t a right shifted signal, and if you observe the width of the signal, here it is 1, here it is 2. So this signal is a right shifted version and then expanded version. To get the right shift we need to have minus sign here. To get the expansion, scaling with constant k value less than 1, so that all are having minus sign, and k value less than 1 needed. So here B and D both are having k value less than 1, that is 1 by 2, 1 by 2. So we can exclude these two options first. Now let us verify with respect to these two options. First I will verify the option B. In B what happens means shifting by 3 right shift and then scaling with 1 by 2. So first, whenever we need to perform shifting and scaling on a given signal, we need to follow the precedence rule. According to the precedence rule, shifting first and then scaling next. So let us take first f of t minus 3. So right shifting of the signal by 3 units, we will get 3 to 4 here, and then scaling of the signal. Scaled version observe here, t value divided with 2. So to get the resultant version, we need to multiply with 2 each instant. So 6 to 8 the signal is. So this is the signal for the option B, which is not matched with the g of t. Similarly, let us verify the D option. In this what we have to do first, shifting by 3 by 2 right shift. F of t minus 3 by 2 will plot first. Then this signal shifting by 3 by 2 right shifted, so that starting from 3 by 2 and 3 by 2 plus 1 it is 5 by 2. After shifting of this given signal by 3 by 2 we will get this signal. Then let us scale this signal. The scaling operation again, a t divided by 2 means we have to multiply with 2. So the 2 gets cancelled here, 3 to 5 the signal exists. Amplitudes does not change while we are performing the operation on the independent variable of the signal. So this signal D option answer is matching with the g of t. So g of t can be expressed in terms of f of t with the expression g of t is equal to f of t by 2 minus 3 by 2. So the right option is D here.